Hello everyone, welcome back to the DSA series. Today we are gonna be learning about the bubble sort algorithm. Now guys, I already made a video on the bubble sort algorithm, but that version was a bit too fast. So this is the improved version with the original speed for better understanding. So what is bubble sort? Bubble sort is a sorting algorithm that works by walking through a list or an array, and it compares adjacent elements, and if they are in the wrong order, it swaps them. This process continues repeatedly until the entire array is sorted. So as you guys can see, we have an array right here with the elements 9, 10, 7, 0, 8, 1, and 2. So what bubble sort will do, it will start with the first two elements, 9 and 10. It will compare those two elements. In this case, we want to sort in ascending order. So we compare 9 with 10, and we say is 9 greater than 10? False. So it moves on to the next element, and then it says is 10 greater than 7? True. So in that case it will swap 10 with 7, and 7 takes the place of 10 while 10 takes the place of 7. And then it moves on to the next element, so it compares 10 with 0. Is 10 greater than 0? True. Swaps 10 with 0. Then it compares 10 with 8. Is 10 greater than 8? True. It swaps 10 with 8. Then it compares 10 with 1. Then it says is 10 greater than 1? True. So it swaps 10 with 1. Then it says is 10 greater than 2? True. So it swaps 2 with 10. Now that is the first iteration of bubble sort, guys. No, the bubble sort algorithm, guys, it is not an efficient algorithm. It only works great on small data sets. You wouldn't use this in a real world scenario with a lot of data. So let's continue watching the bubble sort visualization.
My toxic love, look how you make me happy. You take a hold of me. You take a hold of wish I could give you up, but you're my new favorite drug. Enter into my blood, run with my toxic love. Look how you make me happy. You take a hold of me.
guys, so that was our bubble sort algorithm visualized. So let's move on to our time complexity graph for our bubble sort algorithm. So here you guys can see on the x-axis we have the number of values, which is represented by the symbol n, and the time on the y-axis. So this graph shows that as the number of value increases, the time that the bubble sort algorithm takes also increases. And that is why our bubble sort algorithm is not efficient. It also has a time complexity of O of n squared, which is quadratic time. So let's move on and start coding our bubble sort algorithm. Alright guys, so let's start implementing our bubble sort algorithm. So we'll start by defining an integer array, and we'll make it have unsorted elements. So let's get the size of our array. So size of array divided by the size of an integer. And let's create a function to print out our array. So let's have a void print array, and it will accept a int array, and then it will accept a size t array size. And we will iterate through our array, and then we will print out each one of our individual elements within our array. Now let's test out our print array function. Alright, so we need to pass in our array size. And let's test out. So this is currently our array, guys. Our unsorted array, 9, 10, 7, 0, 8, 1, 2. So let's do a printf up here. Let's say this is our unsorted array. Right? So now let's start implementing our bubble sort algorithm. So let's define a void bubble sort function, and it will accept a int array and a size t array size. And we will start by defining the outer loop for our bubble sort algorithm. So we'll say for size ti equals 0, I is less than our array size, I plus plus. And then we will define our inner loop, which will be similar to the outer loop. So we'll say for size j equals to 0, j is less than our array size, minus I, minus 1, j plus plus. We will then compare our individual element, our current element, meanwhile we're iterating at array, at index j. So we'll say if array at index j is greater than our next element at array index j plus 1. So in this case, this greater than sign indicates that we'll be sorting in ascending order. So then, if this condition is true, we will need to swap our elements. So we'll just call swap, and we'll pass in a pointer to our array at index j and a pointer to our array at index j plus 1. Now we will need to define this swap method. So let's do a void swap, and it will accept a int pointer a and a int pointer b. We will then declare an int called temp, and we will dereference our pointer a to store the old value of a, and then we will dereference a and let it store the value of the pointer b, and then we will dereference b and let it store the old value of the pointer A, which is stored in our temp variable. So now that is our bubble sort function. So let's test out our bubble sort. So let's do a printf sorted array colon new line, and we'll call bubble sort, and we'll pass in our array, then our array size, then we'll call print array size. So now let's see if our bubble sort algorithm works. So you guys can see this is our unsorted array. It has 9, 10, 7, 0, 8, 1, 2, and now this is our sorted array. It contains 0, 1, 2, 7, 8, 9, 10. So you can see it is now sorted in ascending order. Now what if we wanted to sort in descending order? All we need to do is simply change this greater than sign to a less than sign. And now it would sort in descending order. So now you can see the sorted array is 10, 9, 8, 7, 2, 1, 0. Alright, so we can change this back to ascending order. So we can make that greater than sign. So depending on what you want, how you want to sort your array, you can change the signs accordingly. So that is our bubble sort algorithm, guys. So the bubble sort algorithm essentially compares adjacent elements and then it swaps them until they are in the correct order. Now our bubble sort algorithm has a time complexity of O of n squared, or quadratic time. Bubble sort is not an efficient sorting algorithm. It is only best for small data sets. And as you guys can see, it's pretty simple to implement. So that is one advantage of it. But let's say we wanted to sort very huge data, bubble sort would not be an efficient algorithm. There are way better algorithms that we could use. So thank you guys for watching. I will be leaving the source code in the description below. And also, don't forget to smash the like and subscribe button. And I'll see you in the next DSA episode.